Sleep is foundational to human health, yet it's one of the most compromised aspects of modern life. Whether due to work demands, stress, parenting, or shift schedules, sleep deprivation is a common challenge with wide-ranging consequences, from impaired focus and slower reaction times to mood instability and weakened immune function. While no supplement can replace the need for quality sleep, some compounds may help buffer its cognitive effects. Creatine, traditionally known for its physical performance benefits, is now being studied for its potential to support mental sharpness and resilience when rest is lacking. Emerging evidence suggests that creatine supplementation may enhance alertness, reduce cognitive fatigue, and help preserve executive function in sleep-deprived individuals, making it a promising tool in the realm of sleep recovery and brain performance. The rationale behind creatine's cognitive benefits lies in its fundamental role in cellular energy metabolism. ADP, adenosine triphosphate, powers nearly all brain functions, from maintaining resting membrane potentials in neurons to fueling the synthesis and release of neurotransmitters. During sleep deprivation, the brain's demand for ADP increases as it struggles to maintain performance under stress. At the same time, ADP production becomes less efficient due to accumulated oxidative stress and metabolic strain. This mismatch between energy demand and supply leads to a drop in cognitive performance, manifesting as slower reaction times, reduced vigilance, mental fog, and irritability. Creatine offers a way to mitigate this shortfall. As a phosphate donor in the phosphocreatine energy system, it allows cells, particularly neurons, to rapidly regenerate ADP when demand spikes. This buffering effect becomes especially valuable during acute sleep deprivation, when the brain's ability to produce ADP through standard mitochondrial pathways is compromised. By replenishing ADP more efficiently, creatine helps maintain synaptic function, support neurotransmission, and sustain mental clarity during periods of sleep loss. Several human studies have investigated this exact phenomenon. In one study involving military personnel subjected to extended wakefulness, creatine supplementation improved performance on cognitive tasks such as reaction time, memory recall, and decision-making. Other studies have shown similar benefits in athletes, shift workers, and students undergoing periods of limited sleep. Interestingly, the effects appear to be most pronounced in individuals who are sleep-deprived or mentally fatigued, suggesting that creatine's cognitive benefits may not be as noticeable in well-rested individuals, but become highly relevant under strain. Creatine may also influence mood and stress resilience during sleep deprivation. The prefrontal cortex, which governs executive function and emotional regulation, is particularly sensitive to energy deficits. When ADP is low, emotional reactivity increases and frustration tolerance declines. By improving ADP availability in this region, creatine may help stabilize mood and reduce the irritability or apathy that often follows poor sleep. Some studies have even hinted that creatine could buffer cortisol responses, further supporting its role in managing psychological stress under challenging conditions. Another interesting aspect is creatine's potential interaction with circadian rhythms and sleep architecture. While direct effects on sleep quality are not well established, some researchers speculate that by supporting energy metabolism, creatine could indirectly enhance the recovery process that happens during sleep. Preliminary data from rodent models suggest that brain creatine levels fluctuate with a sleep-wake cycle, possibly playing a role in nighttime restoration. Though more research is needed to explore this connection in humans, the idea that creatine could enhance the restorative effects of sleep when sleep does occur is an intriguing direction for future studies. That said, creatine is not a stimulant. It doesn't act like caffeine or amphetamines to force alertness or override fatigue. Its mechanism is fundamentally supportive. It sustains brain energy, allowing the mind to function more efficiently even when conditions are suboptimal. This makes it particularly appealing for individuals seeking to avoid the jitteriness, tolerance buildup, or rebound crashes associated with stimulants. It's also why creatine may complement, rather than replace, other sleep recovery strategies such as light exposure, hydration, and mindfulness practices. Despite its benefits, creatine is not a cure-all. Chronic sleep deprivation carries risks that no supplement can fully undo, including cardiovascular strain, immune suppression, and long-term cognitive decline. Creatine can support acute recovery from occasional sleep loss, but it shouldn't be used to justify or extend harmful sleep habits. Its real value lies in helping the body and brain perform more effectively during those inevitable moments when sleep is compromised, not as a license to ignore the need for rest. In terms of practical use, creatine supplementation is straightforward and well tolerated by most people. A daily dose of 3 to 5 grams is generally sufficient, with no need for loading phases or cycling. Its safety has been confirmed in numerous studies, even over long periods, and its benefits extend well beyond cognitive recovery, supporting muscle mass, metabolic function, and aging resilience at the same time. In conclusion, while creatine cannot replace the healing power of deep, uninterrupted sleep, it may serve as a valuable buffer when life makes rest elusive. By preserving ADP levels in the brain, creatine helps maintain mental clarity, emotional stability, and functional performance under pressure. For students pulling all-nighters, shift workers, parents of newborns, or anyone facing occasional sleep debt, creatine may be one of the most reliable tools to stay sharp until rest can catch up.